So now we're going to learn about acids and bases. Okay, so this is going to be easy. I'm going to break this up into a couple different PowerPoint or a couple different videos. This one's going to be nice and easy. We have acids and bases. So if we look at our little scale of acids and bases, if you remember from middle school or biology last year, we got neutral is 7. Anything less than 7 is an acid, and everything greater than 7 is a base. And the scale usually goes between either 1 or 0 to 14. Mr. G, can it go under 0? Can you have negative acid? Negative? Yes, you can. Mr. G, can you have more than 14? Yes, you can. But we're not going to go there. Okay. So let's take a look at things that we have lying around the house that are acids and bases. Now, of course, it would be fun to check things with pH paper, but we're not going to do that in lab, but you can try it at home if you happen to have pH paper at home. And if you have a pool at home, you should know all about acids and bases because you check your pH in your pool to enjoy a nice pH that is in the pool. So, coffee, tea, acid or base? It is an acid. Lemons, acid. Drano, base. Milk of magnesia, base. It's an antacid. Anti-acid. I'll learn about that in a little bit. Vinegar, acid, acetic acid, my personal favorite, Coca-Cola. That is an acid. That actually has a lot of acid in it, or should I say a lot of different kinds of acids. So it has phosphoric acid, read the label, carbonated water, which is carbonic acid, phosphoric acid, and citric acid. Yum, 3 acids. Yum, yum, yum. Ammonia for cleaning. It is a base. Ivory soap. It is a base for cleaning. And of course, we have pure distilled water, which has neutral. Trick question. It's not an acid or a base. So here is the scale. We have 7, which is neutral, where water is. As we go this way on the scale, the more acid it is. So as we walk across the scale, look, there's milk with the pH of around 6.5. Then we got a banana with the pH of around 5. We got tomato with the pH of 4. We got some vinegar, pH 3. Apple, pH 3. Lemon, nice and sour, is pH of 2. And way on the end here is hydrochloric acid, which is a pH of 0. And notice you don't want to be eating that. Well, these guys notice, yum, 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 eatable. These are eating acids. But notice the other side. Unless you're a vampire, you don't eat blood. But notice, interestingly, has a slightly basic pH, which is very interesting. Then you have baking soda, which is a base. We have soap, which is a base. We have ammonia, which is a base. And really strong at the other end of the scale is a drain cleaner, a very strong base that eats away stuff like fat and hair, which is strong stuff, good for cleaning out your drains. So notice what's on this side. These are cleaners. Cleaners tend to be bases. And on this side, foods tend to be acids. Are there exceptions? Yes. But in general, there they are. So let's talk about the pH. What is pH mean? Oh, go back. pH is the measurement of the hydrogen ions in solution, which is H plus 1. So if it starts with an H, it's an acid. pH less than 7 tells you it's an acid, which means it has more hydrogen ions, H plus ions, than the hydroxide ions. We're going to see that in a minute. pH greater than 7 is a base, and it has more hydroxide ions than hydrogen ions. And of course, if the pH is 7, it is neutral, where the acid and the base cancel each other out, which is going to be important. Notice OH and H. It's going to be important. important. So here's measure pH. Here's the same thing again. If H is greater than OH, then the pH is less than 7, which means it's an acid. If there's more OHs than H's, then the pH is going to be greater than 7, which is make it a base. If the H's equals the OH's, that is neutral, which is 7. And the scale goes from 0 to 14. Well, Mr. G, I only see a 1 here. Yeah, I know. Depends on what pictures you got. And 7, of course, is neutral. So you have this way acid, this way base. Notice acid on both colors are red and bases are blue, which relates to, notice, subliminal here, acid red, base blue. That has to do with litmus test and litmus paper, which, of course, if we had it, you would see that litmus papers turn red. So here's the properties of acid. So it's nice to know them. Write them down if you want, or keep them handy when you take the quizzes. So an acid releases H plus ions in water solution. Now, of course, there are other definitions of what an acid is. This is the simple version. At the end, I'll go into the more complicated ones, which you'll see in college. But for now, all you need to know is H is an acid. Okay, so acids are electrolytes. They conduct electricity. They taste sour, like lemons. They neutralize bases to form salts and waters. Acids react with metals. We saw that already in class. And of course, they react with indicators, which is a pH indicator, which I will show you some of, to produce a color change. And I think I showed you guys this already. And the litmus turns litmus paper red. So the way you can tell this is red and acid. So if you want a mnemonic way to remember, red acid. Are all acids red? No, but they turn pH paper red. So here's some familiar acids that you might know. Mr. G, do I need to write all of these down? No, you don't. But notice something they all have in common. Well, two things they all have in common. Number one, first, we have battery acid, which is sulfuric acid. Mr. G, are we going to have to remember how to name these acids? No, not this year. When you get to college, that's when you need to learn how to name them. This is sulfuric acid, H2SO4, which is found in your car battery. Battery acid is sulfuric acid. Then we have vinegar, which is acetic acid. Yum, yum, yum. We have stomach acid. Your stomach has acid. That's why you take antacid. It has hydrochloric acid. And for folks who have, if you throw up and it tastes terrible, you notice, kind of like not good for your teeth. It eats away at your teeth, so don't barf too often. And then we have lemons and limes. They contain citrus fruits and contain citric acid. And of course, vitamin C, which of course is something that is good and you should be eating, it is also an acid. So are all acid bad? No, of course not. Vitamin C is very good. Lemons and limes, very good. Vinegar, well, if you like vinegar. Battery acid, I wouldn't be suggesting drinking battery acid. That's a bad acid. That's a strong acid. Okay, let's talk about some bases. Bases. Here's properties of bases. A base is a compound that releases hydroxides. They're OHs. Oh, let me show you something real fast. Sorry. Notice all of these, what do they start with? H's. Let's say you can spot an acid a mile away. It starts with an H. Also notice these little AQs are also a gimme. The AQ, remember, means aqueous, which means dissolved in water, which we're going to talk about later in a later section on acids and bases. So when it's dissolved in water, it forms those H plus ions. So notice the H's, it starts with an H. So that's how you can tell it's an acid. Bases have hydroxide ions. They end in OH, and you'll see in a little bit a bunch of examples. They are also electrolytes, which means they conduct electricity. They taste bitter. They feel slippery, which is why the soap is slippery. So don't drop the soap because it's basic. And of course, Bases are also corrosive. They attack things, which of course Drano is really good. And you need to make sure that you wear gloves and goggles and proper PPE and safety precautions when you use Drano because it is a very strong base and it will eat away at what is in your drain, which is good for the drain, but not good if you get it in your eyes. And of course, they neutralize acids to form salts and water, which is going to be important a little bit later. And they also change certain indicators a different color. That color for litmus would be blue. So once again, way to remember, blue base, red acid. It'll be helpful in college. Here's some examples of bases. We got ammonia, which is also called ammonium hydroxide. We got the ammonium ion here, and then the OH hydroxide. We got milk of magnesia, which is magnesium hydroxide, OH2. And of course, this base you can eat. I wouldn't suggest drinking ammonia unless, I don't know, certain presidential people say to do that. But I'm a chemistry teacher and I know better. Don't eat bases. Well, okay. Don't eat the Tide Pods. And don't drink ammonia. It's not going to help you. Milk of magnesia, on the other hand, well, if you have an upset stomach, that will get rid of the acid in your stomach by neutralizing it as an anti-acid or antacid. Now, of course, milk of magnesia helps you do number 2 also. That's the magnesium working on your intestinal tract. So that's something else. Anyway, then we have antacids or rolaids, which contains either aluminum hydroxide, ALOH, 3. So notice the OH is here. And of course, Drano, which of course also is another word, which is lye, which is sodium hydroxide, NaOH, which is very strong base. So if you go to Home Depot and you need to clean out your drain, Drano, be careful, it is a strong base. Okay. Now, of course, you may, if you are want to relax your hair, you may use something that says, "Oh, it says on it lye free." Well, that is an LIE, which is a lie as compared to lye, because instead of using sodium hydroxide, they use potassium hydroxide, which technically is not lye. It's worse than lye. And if you put it in your hair and you have it in your hair way too long, ladies who relax your hair, guess what? You end up with a haircut like mine. No hair on top because it burnt the hair off your head. So next time you are relaxing your hair, don't over relax because if you do, it'll relax your hair right off your head because you're putting Drano on your head. Mr. G, I put Drano on my head? You do. Try not to do it too often, or else you look like me with no hair at all. Okay, so let's go back. Oop, I know. So how do you test for the pH? Well, you could use the litmus paper. Here's litmus paper, and you'll notice the litmus paper, it's kind of like purple in between. It turns blue with base, red for acid. So is a blue state a base state and a red state an acid state? I don't know. You'll have to ask some political person. I don't know anything about that. All I know is blue is base, red is acid. That's it. Now, of course, that just tells you if it's an acid or base. Doesn't tell you much, except it's an acid and base. So what we prefer to use, this is like elementary stuff or just a quick test. They call it the litmus test for a reason. It's a really quick and easy test. It tells you immediately if it's an acid or a base, but doesn't tell you if it's nasty acid or nasty base. So that's why you use pH paper, which is the pH paper over here, which maybe you might see it somewhere. You might see it in the lab. You might see it in chemistry class. And of course, there's also pH indicator, which is liquid. And if you're doing pool work, you've used a pH indicator that's liquid and it changes colors. So those color changes, guess what? The colors, red for acid, blue for base. Notice this one has a 0. Okay, and of course 7 is in the middle, is neutral. So anything on this side is an acid, anything on this side is a base. But Mr. G, look, it doesn't say base, it says alkaline. Yes, same thing, means the same thing. Now, of course, pH paper is what we use in the lab. pH indicator drops, we can also use that. But of course, not everyone has pH paper or universal indicator in their house, except for me because I'm a chemistry teacher. But of course, maybe in elementary school or middle school used cabbage water, which changes colors. Baking soda base, blue, there's that hint again, and vinegar acid, red, and right in the middle is water, which is neutral. You could also use other interesting things over here. Here's red cabbage. Red onion works also, by the way. Turmeric, which is my personal favorite. So it's this beautiful yellow spice. It's delicious in curry. But guess what? If you take that and put it in a base, it turns red. I've never had red curry, and I would recommend that you not eat curry that's red. But I've had green curry, Mr. G. Yeah, it's not red curry, okay? Because that would be in a base. Don't eat bases. Okay. Then we got phenolphthalein. Phenolphthalein is colorless and turns pink. It's really cool. I think I showed that to you guys already. We got bromethymol blue, changes, red litmus. We got that already. Blue litmus, we got that already. And the universal indicator gives us the whole rainbow. So here's a nice little rainbow of test tubes, which I would show you, or I have showed you, or I could show you a picture. But of course, the best way to get real exact amount of pH is to use a pH meter, which is a fancy schmancy, very expensive piece of equipment, which notice, look at the pH. 3 digits, 9.39. The pH paper will give you about whole number, and it's going to be close, because look how close those oranges are, and look how close the greens and the blues are. So it's not very exact. It's good. You can tell if it's a strong acid, a weak acid, or neutral. A strong, neutral, weak base, strong base, which is better than litmus paper. So going up the line, litmus paper just tells you acid base. pH paper tells you a little bit better. You can use other things. Even grape juice and wine changes colors with pH. So lots of strange things change color with pH. But of course, the best way is to use a pH meter. Okay, I think I'm gonna save this for later. Okay, so we'll stop right here and finish the rest later.